All right, everybody. Welcome to another Iron screencast. My name's Paul Burt. I work at IronIO as a developer evangelist. So today's talk is going to be a little more advanced than the introductory video that's on our site. It's going to cover workers, functional programming, and the rise of reactive infrastructure. So let's talk about what all those things are. First, workers. Workers are just a way to run your code in an isolated, safe and secure kind of way that scales easily. It's one of the core offerings of IronIO. So we offer IronWorkers, but they're available in many programming languages and other environments as well. And then reactive infrastructure is an idea to simplify the way infrastructure works and operate with a certain set of principles in mind so that your infrastructure is easier to scale and easier to reason about. And this is often paired with functional programming, so FP in this slide. And functional programming is similar. It's requires a little bit of thinking up front to get the hang of, but once you get the hang of it, the idea is that when a program is written in a functional way, it's easier to read, easier to debug, easier to understand what's happening just by looking at things. So it's supposed to simplify things as well. The combination of functional programming and reactive infrastructure is very trendy right now. It's very cool. I'm going to argue, though, that what is often a better fit for most organizations is workers plus reactive infrastructure. So the pairing allows your current set of employees to just kind of keep doing what they've always been doing when it comes to coding, but you just break things up in a worker kind of a pattern and borrow some of the philosophical roots that are kind of embedded in functional programming, pair it with a reactive approach to doing things, which fits nicely with the traditional SOA type model or service-oriented architecture. And yeah, you've got a great, very clean, simple, easy to expand, easy to build kind of infrastructure setup. So some of this talk is taken from some blog posts and some web pages on the internet. So this is one of the big ones, 2 Pillars of JavaScript. It's part 2, functional programming. So if you want to, if you're the type of person, I guess, who likes to drink directly from the tap, who needs glasses, you can check this article out. And likewise, reactive programming is published online as the Reactive Manifesto. So that's reactivemanifesto.org, I believe. So again, myself, my name is Paul. I'm a developer evangelist here at IronIO, and I'm doing podcasts, updating documentation, writing blog posts, all that good stuff. Cool. So let's dive right in. What is functional programming? Well, as we mentioned before, it's a certain set of steps that allow you to decrease the complexity of understanding your programs. So the important bits that I think are worth sharing in a short cast like this are immutable infrastructure or immutable components and idempotent operations. And we'll dive into what those words mean in a second. First-class functions and higher-order functions, and lists and streams. So you're probably familiar with what a list is. A stream is just a list expressed over time. Let's go through these guys one by one. So first up is immutability and idempotence. So immutability is the idea that you don't change anything, or in kind of more similar wording, you don't mutate anything. So if you have a object or a function operating on something, instead of updating a variable that already has a value, instead you return a value that's a new object or can be stored in a new variable. That's immutability. Idempotence is the idea that when you run an operation multiple times, you're always getting the same result. So you can see that kind of highlighted in this blue arrow diagram here. You're getting the same output from the function, or a similar output from the function when you run this operation multiple times. And more cleanly stated, it's the ability of a system to produce the same outcome, even if a message or event is received more than once. So this is important if you're updating your database. Not all database updates can be totally idempotent, but getting as close as you can to idempotence is always a good idea. So this is one of the core tenets of functional programming. The idea is essentially that your function is containing everything that is happening, all the state, and nothing outside of your function is getting mutated or changed. So that kind of leads us into our next topic. But before we lead on, I like to think of this sort of the real world analog of this is the old saying, nothing can be certain except death and taxes. These are unchangeable things, so they will always be true. And immutable objects are very similar to this. Functional programming. So let's talk about first-class functions. First-class functions, building off of what we learned about not wanting to change things, basically means that you can store the output of a function inside of a variable, and then for a higher order function, you are then passing that variable into the function as an argument. So it's kind of like saying if we can store other data types inside of a variable, arrays, strings, integers, whatever, why not store functions in there as well? And then once you're able to store a function inside of a variable, why not be able to pass that into another function as an argument of that function? So in this case, this is a very simple set of JavaScript, just kind of showing some words being printed. So the first statement is just logging is hungry. The bear variable is hungry, and then that gets passed in and code gets executed that basically says, and now he's eaten. So at the very bottom, we're calling this together, eats bear, and it all kind of just gels. So this is kind of a silly example, just showing what the concept is. And I like to think of this as kind of like a fish eating another fish. So most animals, most predators out there have diets like they feed on grass or other things, but there's some beasts in the wild that eat their own kind. So functions eating functions is kind of like fish eating fish. And finally, if you're passing this information around, functions to functions, that sort of thing, it makes sense to use lists of things as kind of your base, what you start working from. So when you work with lists, you start with this kind of A operator, and then little bits of that list get passed down the pipeline. So the idea here is you shouldn't just wait for the entire list to get processed. So you have 10,000 emails you need to send. You don't need to wait for all 10,000 of those to get read into memory. You can start piecemealing those out to these additional pipelines down the chain. You can either pass it message by message or maybe in chunks of 10, chunks of 20, whatever makes sense for you. So usually when you see code like this, it'll be kind of laid out with this dot syntax, but both these top and bottom representations are basically exactly the same. And the idea here is it's very easy to see what's going on, and because all of the state or all the things that are being affected are inside the functions, it's very easy to debug things or trace what's happening inside your programming or code there. An important reminder, we mentioned it earlier, but a stream is just a list expressed over time. So your list is there all the time. It's just you're not waiting for the whole list to get processed when you're working with streams. So this is a more concrete example of a stream or a list getting operated on. In this case, I'm not actually streaming, but these are functions that are used to stream things. So this is a good use case just all around for how functional programming sort of works or looks. So we start this off with an array, which is a list of things, of numbers. And then we are mapping that array to the square root function. So the output of that is 1, 2, 3, and 4. Then we are filtering that list to values that are greater than 2, which just leaves us 3 and 4. And then we are reducing that list to the addition of all the values that are inside of it. So adding 3 and 4 produces 7 here. So this is a nice, easy way. You can see what's changing, what's happening every step along the chain. And if you need to debug things, it's easy to just throw in a little print statement here or there to see what the state of things are as they kind of flow through this whole process. So working in this kind of a way with functional programming is kind of like an assembly line, which is beautiful. Simplifies things. It's very easy to think about. You don't have to jump through hoops to replicate state based on some crazy steps users took in production. That's awesome. So let's hop over to the Reactive Manifesto, which is talking about reactive infrastructure. So in short, basically the Reactive Manifesto is just saying that the demand for web apps and speed and good infrastructure is just going to keep increasing. So today's demands are not met by yesterday's stuff, and tomorrow's demands are not going to be met by today's good infrastructure practices. So this is just kind of a shot of an old Greek temple that's been updated as a church, kind of showing how clunky that can kind of be to reuse old stuff to fight new problems. This is a diagram taken directly from reactivemanifesto.org. Let's kind of step through what each of these pieces mean. What's important is that all of these bits kind of feed into each other when it comes to supporting each other's goals. So responsiveness, in short, is just that you want things to be fast. You want your system to respond to actions quickly. So as we mentioned earlier in functional programming, you don't want to just wait for all 10,000 items in a list to load before you start operating on it. You want to stream that content so the next step in the pipeline can get working on things. So that's responsiveness. You want resilience. That means your architecture should fail gracefully. So in a functional programming example, if one individual element in a list or a stream has an error, what will usually happen is it'll either get set aside or handled, and whoever needs to be notified about that will be notified. It doesn't cause the entire list of 10,000 emails to stop processing. If you're sending 10,000 emails, it just sets that one email aside and then keeps working through the rest of the items there. So you want isolation and replication of your content to get resiliency. You want it to be message driven, and the point here is that if you are just emitting events, you're requiring both your applications to be online at the same time and be able to connect at the same time. And in a distributed kind of infrastructure, we know that's not always possible. So instead of emitting events or like doing a direct messaging type thing, store your stuff in a message queue and use the message queue to route information so things can ask for the next chunk of stuff to work on whenever they're ready for it. Finally, you want your infrastructure to be elastic. So it should scale simply and it should scale horizontally. You shouldn't have to jump through hoops to get more performance out of your system. So, you may have picked up as we were jumping through that functional programming and reactive programming are a pretty cool trend. And they fit together on a lot of these pieces really nicely. What I'm going to argue, though, is that functional programming is not all that intuitive to a lot of people. So if you're working on a small team, it's totally fine. It's easy to train them up on it. But if you're working on a larger team, the canonical team that can't be fed by more than 2 pizzas, then it's a lot harder to enforce and get everybody on board with. So what I like to recommend is why not use workers? So we should talk about what workers are. So workers are essentially just the Unix philosophy applied to normal object-oriented or procedural programming. So in Unix, if you've ever seen someone use a little pipe signal to pipe content around, then that is the basis of streams in your command line in Unix. So workers are exactly that for your code. You want to write a little bit of code that does one thing and one thing well, and then you want to run that code, and when that code's done processing that one thing or the 10 things that it's working on, pass it on to the next item down the chain, the next worker that's going to do some operation. So if you're working in the email space, this is kind of like you might compile a template for an email, then queue the job up with whoever your job processor is, and then the job processor will hopefully send those emails out to everyone. And workers also check all these boxes really well. So there's not a lot to really rethink when it comes to workers other than following that Unix philosophy, make code snippets that do one thing and one thing well. So you'd have one code snippet for generating templates, one for queuing the job up, and one for verifying that the client received the message correctly, as a for example. And the ultimate outcome of this is you don't have to retrain your team. It's a very easy and simple way to reason about your infrastructure, the same way functional programming is. Debugging is very simple. Workers also, if a job fails with a worker, it'll automatically be re-queued to be done again. And if that fails a certain number of times, you'll receive that error email. So workers are also very resilient in that way, and they are also naturally isolating work between tasks that are happening. And now let's take a look at a worker. So you can actually head to iron.io/worker if you just want to see a website that details that information. I'm going to show you a little bit of stuff around sending emails, since that's the example we've been using with Iron Solutions here. Alrighty, so let's take a look at some code, just some simple stuff. So I am going to open up a hello.ruby script, and Ruby is notoriously not parallelized, not asynchronous. With workers, we don't really have to worry about that. Workers are automatically highly concurrent, highly parallel. So I'll open this guy up, and hopefully Atom does its thing. Cool, and let's enlarge this a little bit. So what's happening here? We're requiring our libraries that we need to load into our file, and then we're taking some action. So the first step is to read the payload. This is the individual message or 10 messages we might need to operate on. In this case, it should be an email address. Then we are taking that payload and processing it as a JSON document. You can have your payload be delivered in whatever streamable format you like, but or serializable format. We like JSON here as a good standard. And then basically just building out a list of values based on that JSON format. So I can click over to my hello.payload JSON that I have as a test JSON file here, and I can see it's just testing today at thatmightbe.com. Very simple. And then basically for each element in the array, which should be an email ostensibly, we are sending a curl to the Mailgun API to process this. So I should note that it's very bad that I am including the API key directly in the code here. Iron does allow you to use environment variables, but this was just a quick project for me, so I'm not too concerned about it. I'll be deactivating that key in a little bit. So great. I have this code here. All I need to do is package it and upload it to Iron.io. So we have some guides for how to do that using Docker. Assuming you know how to do that, or since I already have done that, I can actually log into hud.iron.io. That's hed.iron.io. And then I can view my job here that has that information. So I can see I've got this project named Real Fine, and the code that I've uploaded is called Deal Time, and I've got some tasks that I've queued for it. So if I want to click in, I can see the status of each of those tasks, how long they took to compute, And then I can also click on one of the task labels to see what code was actually executed. In this case, it was just simple Ruby invocation of the script. And then I can see which email address I was actually emailing for this instance of the execution. So in this case, it was stevez@thatmightbe.com. So very simple, very easy to trace what's happening. And basically, if I go back to tasks, or actually, let me click into deal time. I can see a concurrency for how many workers I have running at a time. So this is on the free plan, which is bottlenecked by other users on the system. We want paying customers to get preference at Iron.io, but I still get a concurrency of up to 5 workers sending these bits of email at the same time. If you're a paying customer, this value can basically be whatever you want, whatever fits your sort of infrastructure or your needs that day. So basically, we start using compute resources, and then when we're done using them, we release them again to be used by something else. So let's queue up some jobs and see what that looks like. So I've got another script here called emailq.rb, and I am requiring the handy IronMQ gem. I've got a MQ set up that basically just will push jobs over to the worker here. I could also queue directly to the worker. This is just illustrating the interplay between these two systems. Whatever works for you, whatever is easiest is definitely the best way to go. But as we mentioned earlier in the reactive kind of manifesto, message queues are the way to pass information around, and each worker innately has a message queue tied to it. The only reason you'd want to use a message queue like this is if you want to add channels or multiple recipients of an individual message, that sort of thing. So in this case, I've got my queue set up to send 10 messages at a time when I run this script. So I should be able to invoke that. So it's Ruby, and then basically this guy, email queue, and then I'm just naming the queue name. So that's basically the queue name is what's being processed at the top of the script here, and then this bit iterating through a loop of some number of items to generate emails, messages that I want processed, basically. These are building the payload messages for each worker. So let's run that guy. So our information has been sent to our message queue. Our message queue is whirring to life right now. And hopefully, if we go back to our tasks page, we'll start seeing some unrun tasks. So yeah, we can see we've got some messages starting to trickle in. We've got 2 that are currently running. And if we keep refreshing the page, we should see these numbers start to change. So the numbers that are running concurrently went down, but our number of messages that we've already sent jumped from 27 to 30. So we can tell things are working. And obviously, this is even faster when you're a paying customer. But yeah, this is the worker kind of model in a nutshell. So you can build this out yourself. There's a lot of open source solutions that do this, but they're obviously very involved and tricky. Or you can try out IronWorker for free, as I've done here. So if you're interested in getting started, you can just go to iron.io/worker, read about the system, see if it's a good fit for you, and then sign in or sign up here, one of these 2 guys, and you'll be off to the races. So that's it for today's video. Appreciate you joining us. If you have any questions, feel free to send me an email at paul@iron.io. And yeah, happy coding.